Alrighty, y'all. Welcome. Happy Saturday and welcome. We're super excited to have you all. And we are at the end of week 2, y'all. Technically, it's our third Saturday together. So we're almost at a month of being together. So in terms of today, I want to go over a few things for you all, or with you. So I want to um share some updates to the training site. So some folks have been so first off, disclaimer, mini project, right? I've seen that a lot of folks are working on the mini project. Great. If you're working with your team, phenomenally. Want to reiterate that the mini project is a team assignment, right? So you're supposed to work with your team. It's not an independent assignment. And what we're going to do, right? There's a lot of questions coming in for our extra help, our TA channels, etc. We're going to do this for our TAs that are here. The first thing that when you ask a question in extra help or anywhere else regarding the mini project, our first response is going to be, have you checked with your team, right? That's going to be our first response. If you checked in with your team, then we'll answer your question because we want to make sure that you all are utilizing each other, helping each other, communicating, right? That's one way that we're going to enforce or reinforce that you all are working with one another. So for our TAs, right, if someone asks about a mini project, first response is going to be, have you checked in with your team? You can also just come and say, yes, I've already asked my team, etc. Right? But communication, we're gonna emphasize communication as we're working together. So mini project, going over that. Again, also, I've seen a lot of folks stress. It's okay for you all to be stressed, right? We assigned the mini project and we made the deadline due the 14th. The reason why we didn't make it due the 8th or the 9th, etc., was because we understand that there's content that we haven't gone over that we will review today that will help you in addressing the mini project. So it's okay. Take a breather. You're fine. And if you need any help, we have additional support. So that's actually what I'm going to emphasize right now. So I want to take us to our training site. So you'll see that I posted a video in terms of office hours. So we have officially opened our office hours for you to schedule any time that you want to meet with a TA. You can find this specifically in the resources tab. So once you're in the resources tab, you can click under the forms section, right? Drop down menu. You can click the forms and you'll see office hours. Once you're here, you click on this and you'll have the option to either set up office hours with TAs or with staff. And so these will be 30-minute meetings. So for whatever reason, let's say you want to meet with someone on Sunday, you check automatically Calendly is synced to your calendar to show when you're available. And it'll also show your time zone here. So you don't need to do anything. So once you click on this, you confirm, etc. At the end of this process, as I mentioned in my video, you'll see who you will be meeting with. You should receive a calendar invitation, and the TA that you're meeting with will also receive a calendar invitation. So that way, both of you all know who you're meeting with. If for whatever reason you need to reschedule, you need to cancel, you need to, one, notify the TA, and then two, also go through that process online. So you would cancel or you would reschedule and provide a reason. So that's there for you all. In addition of additional supports, we also know that some folks are struggling with like Excel, need a little bit more exposure, need a little bit more help and support. We have you 1000%. So if you scroll over to our calendar, you'll see a few things that are happening additionally. So after our Tuesday and Saturday sessions, our TAs are going to be offering post-lecture support on these same Zoom links. So if for whatever reason you need to clarify, you need a little bit more clarification on what's happening in that specific lecture, on Tuesdays, we will have 3 TAs available to help you all clarify those things that you need. And then on Saturdays, we will also have the same thing, post-lecture support after these lectures. So for an hour, TAs will be available to help clarify any things that you all have, any questions that were left unanswered, etc. Okay, so this is stuff that we're providing. In addition to this, it's not on the calendar yet because it kind of slipped my mind, but I'm going to include it on here. We are doing on Thursdays a tech/intro Excel support. So it would be 9:30 p.m., I believe, Eastern time. So for those of you on the Pacific Coast, 6:30 p.m., etc. That's where Todd, myself, and maybe a few other staff will be available to answer any questions, anything that you all need specifically with like introduction to Excel. So once I will update this during this session, so you will see it on the calendar reflected on our training site. So those are the few things that I wanted to mention. Let me just triple confirm that there's nothing else. Corinne, yes, what's your question?
Hi, I just wanted to know, are you guys going to also add Python training to this?
Great question. Yes, and
Thank
that's what's on the top of my list. Yes, so we're going to be offering 2 optional tracks for you all to enroll in. Python is going to start hopefully next week, once we come back from the break. And then statistics will be offered later on, probably week 11, week 12, because you need a little bit of pandas knowledge in order to get started with statistics. So letting you all know now that Python will be starting next week, which is wait, this is week 2, that's week 3. It would be starting week 4. So
Okay.
the week we come back after break.
Thank you.
Yeah, you're welcome. Zachary, you have a question.
Yeah, what if you have to work during that Excel introduction?
Great question. We can record it and we'll make it available for you all.
Oh, okay, cool. Thank you.
Yeah. But just know that it's not structured, right? It's not like lecture. It's not like, hey, we're going through these exercises. It's very much like, what questions do you have? You bring those questions and we address them. So
Okay.
it might look a little haphazard, but we'll record it and we'll make it available for you.
All right, thank you.
Yeah, you're welcome. Last thing, lecture recordings. So I wasn't able to upload the recordings because I had a trip, etc. All recordings will be posted after lectures and will be made available after the content, maximum 3 hours after. So actually, please check the website on Sunday mornings because the recordings will be available then. Yeah, we have a question. We have time for one question. So Abimbola.
Hello.
Yes.
Yeah, I wanted to ask. On Tuesday, you said we're going to talk about the mini projects. So
Yes.
is there like a deadline for us to submit the assignment before that, or what? You know, because
Yes.
there's no deadline on submission.
Great question. So this doesn't say the time, and I love that you brought this up because this is actually my last point. So the mini project is due during this time. You will notice that on Tuesday, we will, as our content has already shown, right, we're reviewing mini project. So that means we're gonna go over the answers, how you all solved it, etc. So the project is gonna be due Tuesday at noon Eastern. So 12 p.m. Eastern time, since our content starts at 2 Eastern. So mini project is gonna be due at 12 p.m. 12 noon. Yes, noon. Great. Alrighty, y'all. Well, I hope that clarified questions and I hope that helps answer some of the things you all might be experiencing, worries, confusion, etc. So now what I'm going to do is I'm going to pass it over to Viviana to take us to go over today's content.
Sounds awesome. Hi, everyone. I'm very excited to be here to see all of you again. So just give me a couple of seconds while I share my screen. All right. So are you guys able to hear me, see my screen? Everything works fine? Awesome. So I'm very excited to be here. Good morning, good afternoon, good evening, because I know that we have people coming from all over the place, all over the world joining us today. So today's case is called Which Car Makes and Models Are the Most Popular in the US? So let's just get started. Let's talk about the business context. So it's the year 2020. And you work as an analyst at a small car dealership. The dealership is planning to expand its marketing campaigns to give better coverage to car makes and models that have proven to be more popular with customers. That is that the company that you work for, they just want to be able to know which cars are the most popular ones so they can have them ready for customers to buy. So for the business problem, your job, should you choose to accept it, is to write a short report that summarizes car sales data from the first half of 2020 in the United States. So this is coming from actual data, real data that was published in Forbes. So you might notice that the data through this time is low. It's abnormally down compared to other years because it was 2020, was the pandemic. However, you can use this data to do the analysis that we'll work throughout the lecture. So you want to be able to provide your boss in this scenario with your report about which cars were the most popular, the ones that were sold the most, to be able to make decisions. So just as a quick reminder, you can always access through the training site, the fellow case, so you can follow along this lecture. And if you have any questions, any comments, you can use the live chat. I'll try my best to be looking to the site. So I'm looking at the chat and seeing what are all you thinking and how are you all feeling. But don't worry if your question doesn't get answered live, because our wonderful team of TAs will be there right there answering your questions as well. So what is the goal of this lecture? So for this lecture, by the end of this case, you'll be able to interpret tables, bar charts, and pie charts. And you'll also be introduced to the concepts of absolute and relative frequency. So this is the business context that I just gave you. So you're going to write a short report that summarizes car sales data in 2020. And if any of you is curious where this data is coming from, you can just click on this link and you'll be able to see this article with all the data. But you don't have to worry about that right now, because we are going to provide you with all that data right here. So first, let's start with how to read a table. So something very, very important that we're going to be using as data professionals are tables. So tables are made up of two things. The first one is columns. So columns are the ones that go vertically, and then rows, the ones that go horizontally. So rows, for example, this is a row, another row, another row. So rows typically represent people, transaction, items, or anything in general, any object in general. And then columns, the ones that go vertically. So here we have one column, the other column, the other column. Column usually represent characteristics or attributes for those things that we have. So for example, in this table, we have the columns. So we have the first column is first name. So the first name for each one of our people in this table. Then we have the second column is last name, and the third column is favorite food. So I like Anna already because my favorite food is pasta. So in this specific instance, rows represent people. So in our case, the data points that we're dealing with is people. And then the columns are just the information that we have about each one of these people. So in this case, we have their first name, their last name, and their favorite foods. So also another terminology is the word cell. So when we use the word cell, is just to express each one of the boxes where a column and a row meet. So for example, this cell contains the value Anna, and then this other cell that I'm highlighting here contains the value burger, etc. So usually when you want to read a table, what you do is that you start locating the row that you're interested in, and then the column. And then you also want to find more, if you want to find more about certain characteristics of the item that you're looking for, you first locate the column and then the row. So let's just look at some examples. Let's go with the first example. So the first example is a question, and this question says, what is the first name of the person whose last name is Fisher? So let's look at the table again. So we know that we're looking for the last name Fisher. So we go to the column that has the attribute last name. So this is the column with the attribute last name. And we want to find Fisher. So we see Fisher right here. So now that we have located Fisher, exactly. Oh, I love it. I'm looking at the chat and I love it. Everybody knows that the first name of the person Fisher is Jen. So you all are on top of this. So let's continue. So yeah, as you guys are mentioning on the chat, the answer is Jen. So now let's go with an exercise. So what's Anna Stevens' favorite food? Awesome, pasta, exactly. So we knew that we have the first name and the last name. So first name, Anna, last name, Stevens. And then the question was like, what is her favorite food? And it's pasta, just like me. So this is my day today because I love pasta. So I'm happy that that's there. So let's go with this is just the answer. So let's just go with another example. But before jumping into that other example, let's introduce the concept of frequency tables. So tables are in general very useful to represent any type of data. And I'm personally obsessed with tables. I usually put everything that I can think of in tables, and you get to see interesting things about it. For example, I have a table, an Excel sheet where I keep track of all the flights I've ever taken in my entire life. And I have just a bunch of information on it. So I have which airport did I fly from, which airport did I fly to, which day of the week it was, what time it was, how long it was the flight, etc., etc., etc. And recently I was looking at all this data that I had of all the flights I had ever taken to. And because I had this data, I was able to compute some statistics on it. And I realized that I have spent a month of my life flying. So if I would put all the flights I have ever taken together, I would just spend a month on a flight. So that's a cool thing about tables, is that you can take any type of data that you could possibly think of. For example, in my case, I took something that it was related just to my personal life and my joy for travel. And I was able to see that. I was also able to see which day of the week I traveled the most, etc. So tables are very, very, very powerful, and they're very useful to represent any type of data. So it could be a medical record, it could be in a medical record in a hospital database, it could also be your entire network of friends on Facebook, etc. So you name it, you can probably put it in a table. So there are many different types of tables, and one of the most frequently used ones are frequency tables. And that was a pun intended. Because frequency tables are one of the most frequent used ones. So these tables are tables that list how often a particular element appears in a data set, that is its frequency in that data set. So basically, a frequency table, to put it in simple terms, is a table that contains a column, and that column has counts of, it gives you a counts or frequency of those elements. So let's just look at an example. This is the car sales table that we were talking earlier today, of the I love the memes that I'm seeing in the chat. So this is the car sales table of the business case that I presented to you earlier in the lecture today. And we have extracted only the 10 highest selling car models. So we see here the column with the make, the column with the model, and the column with cars sold from January 2020 to June 2020. So my first question for you, all of you, is, can you say, why is this a frequency table? I would love if you guys can share your thoughts with the class on the chat. Exactly. So John is saying this is a frequency table because it lists how often a particular car make and model is sold. I wouldn't say how often, but I would say like it counts how many cars of that make and model were produced in that period of time. So I'm continuing to reading your answers. Exactly. So Ted says the table enumerates the sales of vehicles by make, etc. So exactly. So basically, a frequency table is any table that contains a column that has a count of your items. So in a way, you can think of it as an aggregated table. You could have an extended table where each row would be the specific car that you have with the make and the model. So for example, Ford and Model F series. And then once you aggregate them, you can count like there's 300 over 300,000 of them. So let's move on to our second exercise. And let's answer these following two questions. So what was the model with the highest sales and how many Honda Civic units were sold? So let me just show you the table again. So the first question was, what was the model with the highest sales? Well, I'm seeing Ford and I'm seeing F-Series. So the question was, what was the model? So if we wanted to be super precise, the model would be the values on this column. So the answer would be F-Series. Of course, you can always give more details. So it would be the F-Series and the make was the Ford, etc. But yeah, that's pretty awesome. And then the second question, and then something that I wanted to point out is that it was so easy for us to come up with this answer because this table is sorted in descending order. So we knew that the highest value would be at the top. Our task would have been harder if this table was sorted randomly. And then the second question was how many Honda Civic units were sold. So in this case, we're given two informations. So we go to with the column. So the make is the Honda Civic. So we have Honda and we have two Hondas in this case. So that's why it was important that they also told us the model, and the model is the Civic one. So we can quickly answer, as I'm seeing in the chat, 127,858 cars were sold during this period of time. Awesome. So now that we've looked into tables and how to read them, we're going to jump into bar charts because sure, we have the table, we have all the information, but can we represent it in a different way? Because our job as data professionals is to not only come up with statistics and analysis, but also being able to communicate them. And sometimes the best way to communicate them is using visual aids. So let's just jump into some of them. Let's start with bar charts. So the car sales frequency table can also be represented graphically via this bar chart. So bar charts are one of the most popular ways to represent data. And in a bar chart, you have a set of bars, one for each row in the table. So let's just look at this bar chart closely, and let's see what can we read from this bar chart. So I'm looking at the chat, and I love that someone brought the reference about the scribe that we mentioned during the first case. So as data professionals, we're the modern scribes because we are able to read and write data and translate it to the people that are our audience. So let's just discuss more about the properties of this bar chart. So first, we have the titles. So for example, here, the title of this bar chart is Sales of Cars Between January and June 2020, Top 10 Models. It also has a subtitle, and you have the axis labels. So over here, we have the x-axis, and over here, we have the y-axis. And as many of you are pointing out on the chat, this is nice because it's easy to read, and the information is clearly communicated to your audience. So let's just look at the axis. So for reference, usually the horizontal axis, it's called the x-axis. And this one, in this case, it's called the name given to it is the model. So we can see the names of each one of the models that we were offering in our top 10 models. And then we have the y-axis. So for the y-axis, we have units sold. And as you have noticed, also in addition to the axis, we have the title and the subtitle. And the subtitle provides the information where this data was obtained from. And this is really a really good practice because it helps readers understand where the data is coming from. which also gives them a sense of trust into the data. For example, me as a data professional, whenever I see a table, I don't take its word for it. I always want to see where they getting this data from, because it's important to know that we have data that has good quality and that we can trust. So another important part of this table are tick labels. So for the tick labels on each axis, so in the case of the x-axis, we have the tick labels, so the names of each one of the elements that we had in our table. And then for the y-axis, the y ticks represent the magnitude, so how many units were sold. And then finally, the last part of this bar chart is the bar labels and the grid. And this is very, very important because this is going to allow you to understand the quantity of that you're talking about. So the height of each bar is proportional to the frequency associated with the respective model. That is that the taller the bar, the more units were sold for that particular model. So for example, for the Ford F-Series, we see that it was sold the most. So it has the tallest bar in the plot. And same with GMC Sierra, it's the lowest one because it was the one with the lowest number of cars sold. So sometimes we see labels on top of each bar, and those labels tell us exactly the number. However, that's often unnecessary because you can also just use the information that you have in the y-axis and the gray lines that you have in the chart. So, and those are called the grid. So for example, we can quickly see that there are 1, 2, 3, 4, 5, 6, 7, 8 gray horizontal lines in our chart. And even if we didn't have this number right here, we will be able to see that the sales of Ford F-Series would be between 350,000 and 400,000. So now let's go on to exercise number 3. So for exercise number 3, one of the main advantages of bar charts is that they allow you to quickly compare different bars without having to look at the actual numbers. So that's exactly what we were just talking about. So this is the same bar chart that we were looking just now, except it doesn't have any numbers. So we don't have any numbers in the y-axis, and we don't have any numbers on top of each one of the bars. So by just looking at the grid, without looking at the numbers in the previous plots, pick 2 models that one has sales that are approximately twice those of the others. So you could phrase your answer like model A has approximately twice the sales of model B. So I'm going to be reading your questions, your answers here in the chat. Yeah, exactly. So I'm seeing a lot of Ford F-Series and Toyota RAV4. So you can see that the sales of the Ford F-Series extends just about the 7th grid line. So it's almost 8. So 8 divided by 2, it's 4. But since it's not quite there at the 8 mark, it's like the one that would be half as much would be almost at the mark of 4. So 1, 2, 3, 4. So this one is almost at the mark of 4 of the 4th gray line. So that's a good example. I want to see if someone else can think of a different example. Exactly. So I saw someone over here saying the Ram pickup and the Honda CR-V. So let's look at it. So the Ram pickup, it's over here. It's the third one. And the other one is the Honda CR-V. So for the Ram pickup, how many grid lines do we have? So 1, 2, 3, 4, 5. So one that would be that has cells that are approximately half of those would be 2.5, approximately 2.5 grid lines. So 1, 2, and 3. So the Honda Civic is actually a better example. So Honda Civic 1, 2, 3. So 2.5. You could see this is like in the middle between the 2 and the 3. So the Ram pickup and the Honda Civic would be another example, because the Honda Civic has approximately is the keyword here, twice those of the other one. So those twice of the Ram pickup. Exactly. So now let's just move to exercise 4. So for the exercise 4, we have added the tick labels back into the chart below. So I'm just gonna make this chart bigger so you guys can see it more easily. So try to validate the answers that we were just talking about from the previous exercise. Can you do it easily? And I think, for example, one example was the Ford F-Series and the Toyota RAV4. So if you look close to this table, you see that there's something wrong. Can anyone notice what's something wrong? What is wrong with this table? Exactly. So I see here that Darren and Nia, they noticed that the y-axis doesn't start at 0. So that just give us a different perception of what the cells were. And this is usually not a good practice. So although it is very important that you always check the y-axis and make sure that the y-axis starts in 0, because it can be misleading. So although this plot and the original one display exactly the same information, the same frequency table, they look very different. And because this y-axis doesn't start in 0, but instead it starts at 100,000, it creates the illusion that all the bars have shrunk. So if you notice, for example, the GMC Sierra was a little bit taller before, now it's like very, very shrunk. So those that had the shorter bars to begin with, now they're even shorter. And this is misleading because the relative proportions between bars are lost. So for instance, the Ram pickup that we were just talking about, the cells for this model looks much more greater than the Honda Civic, where in reality, it's only a difference of twice as much. So now you're going to start noticing, now that you know this, you're going to start noticing whenever you check the news, you're going to find yourself making sure that the bar plot starts at 0 and not at 50. Because you'll notice that, for example, when they're talking about elections and they want to portray like, oh, this candidate had more votes than the other candidate, and they show you a bar like this, you would think that candidate A has more, like twice as much votes as candidate B, when in reality, if you plot it from 0, you'll see that the difference of the height difference between the two bars is very, very slim. So it's very misleading to not start the chart at 0 and start at a different number. So there could be occasions where this is justified, but in general, this is a bad practice. So always try to start your bar charts with the y-axis started at 0. So now that we have seen bar charts, we can also look at pie charts, but I want to stop for a moment here before we jump into pie charts and see if anybody has any questions. So I'm checking at the live chat. I love that everybody's participating. Someone is asking in the chat, what is the solution for this case if it's not starting from 0? So if you're the data analyst, the data professional creating this visualization, you should start it at 0. It's bad practice to not start it at 0. If it doesn't start at 0 and you're not the one that created it, start asking questions. Why did they do that? Did that make sense? Am I being misled the way that I'm reading the information just because the y-axis doesn't start at 0, etc. This is a very good question. So someone in the chat asked, like, why would anyone start at any number other than 0 except to be misleading? There could be cases that for whatever reason, it just makes more sense to start at a different number, or maybe if you want to just assume of what the actual difference was, you can start at a different number, but you should always, as a data professional, be very transparent and put maybe a legend that says, like, notice that the y-axis didn't start at 0, so it's not misleading. Because if you want to be a data professional that also has ethics and good practices, you would do that. All right, awesome. So now that we have seen bar charts, let's jump into pie charts. So bar charts are not the only way to represent data that we can count. And the other way that we can represent it is with pie charts. So it's a very, very popular alternative. And the reason why it's called a pie chart is because it actually looks like a pie. So for me, it's right now Saturday in the afternoon, so I'm like thinking about pie, like pie. But yeah, so that's where the name comes from. And then each category gets a slice of pie, and the size of the slice for each category is proportional to the frequency of the category in the frequency table. So in other words, the more frequent a category is, the larger the slice is going to be. And I see that we're all here excited with pie charts. So pie charts are good for representing frequencies, not only as absolute numbers, but also as percentages. And this is another key concept for today, because we were talking about absolute frequencies and relative frequencies. So a relative frequency is just the percentage. So a relative frequency in a pie chart, let's say we only have one element, like one category, then the total area of the pie is considered to represent everything. So 100% of the pie chart. So let's say we only had Fords, the first type of car, then it would just be the whole pie chart. So for instance, to go back to our example of the car sales, we sold over 1 million units, almost 2 million units. Therefore, the total area of the pie chart that would represent the total number of sales would be 100%. So it would look something like this. Yeah, so exactly. So I'm looking at the live chat. I'm seeing some people online saying that they would grab 2 equal slices of pizza. So guess they're very hungry. Okay, so this is 100% of a pie chart because we're representing only the total number of sales. I see that we have a question, Lily, and please correct me if I mispronounce your name. I think you're muted if you're talking.
Yeah. My question is, hello.
Hi.
Hello.
Yeah.
Okay.
And we can hear
My
you.
question is, in the chart, if you got a negative number, you're supposed to starting only by 0, because sometimes it's like.
That's a great question. So you could have the case where your for example, if you're selling cars, maybe you wouldn't say that you sold negative cars, but you could be in the context where you're representing losses. Then in that case, you will have negative. So the y-axis wouldn't necessarily start at 0, but you will mark the 0. You will highlight that in the y-axis the 0, so you can easily denote that you have negative quantities and then positive quantities. So just to rephrase myself, you would have the y-axis, and then above the 0, for the y-axis above 0, you would indicate the positive values, and then below 0, you would indicate the negative values.
Okay. Thank you.
Yeah, of course. Yeah, so it depends. I'm reading at your messages here in the live chat, and that's correct. So sometimes you can't have a negative number, but sometimes you can, depending on the context. So just make sure that in your context, if you ever come across a negative number, that it makes sense in your context, and that it's not like a random fluke of your data. Maybe someone accidentally typed a negative number in your cell in the table that you have. So it's always to be attentive to all those things. That way you're making sure that you're representing your data correctly. All right, so now let's go with more with the pie chart. Let me just make this bigger so it's easier for all of you to see. So now we have the car sales by model. We have the top 10 models. But now let's just look at the top 10 models, but let's just look at the car that was sold the most, which is the Ford F-Series, and the other models. So let's just gonna group all the other models and look at all the other models and the Ford F-Series. So as we saw from our table before, we see that the Ford F-Series sales amounted to 367,387 units sold. So that's 20.5% of the over 1 million units that were sold. So that's almost 1/5 of the total sales, which means that 1/5 of the pie chart area should be assigned to the Ford F-Series like this, as we see in this pie chart below here. So one nice thing about the pie chart is that you can quickly see that without looking at any numbers, that the Ford F-Series represents about 1/5 of the sales of the top 10 model sales. All right, so I'm just looking at the different questions in the live chat. So some of you are asking, how did I create this pie chart? How did I added all of them? We're going to be looking at this in future cases, because that's going to be, once you're working on Excel, you're going to be creating aggregate functions depending on the type of analysis that you want to do. And also there's a data visualization case in the future later on, where you'll learn how to make these bar charts and pie charts and etc. I hear you. I see that some people in the chat are saying pie charts don't seem as easy to read as bar charts. And throughout the years, I've had colleagues that feel very strongly one way or the other. They either really like bar charts, or they either really like pie charts. So it depends, up to you. But we'll see a few examples next of when a pie chart wouldn't really be a good idea, but when both are a good idea, then you as the data professional have the right to make the choice whether to use a pie chart or a bar chart. So going back to this pie chart that we have right here, we have two categories. We have the 4F series, which is the red one right here, which accounts for the relative frequency of 20.5%. So that's a key term right there, relative frequency. So whenever you hear relative frequency, we're talking about percentages. And the advantage of relative frequency over absolute frequency is that for us as humans, it's easier to understand percentages. If I tell you that the 4F series sales amounted to 367,387 units over the total 792,146 units sold. That's the absolute frequency, but it's too many numbers. It's hard to grasp right away. Where if I tell you 4F series sales amounted to 20.5%, you quickly get an idea of how many sales were there in comparison to the rest. So that's the relative frequency. The relative frequency is the percentage. And then for the other models, on the other hand, we have that for the other models, the relative frequency was about 79.5%. So one thing to notice right here is that if you add the two of them, they should always add to 100%. And this is one of the things that I like about being a data professional, because now I think of myself as a data snob, because whenever I see data online, I'm always trying to see if they're portraying the data correctly. And you'll be surprised to see how many times people create pie charts online where the total is not 100%. And that doesn't really make sense, because then the representation of how big each slice is becomes meaningless if your total is not 100% of the information that you're trying to show. So that's one thing that is very, very important about pie charts, is that they should always add up to 100%. Another thing that you can see is that this pie chart has this text right here. So just to take a few steps back, just like the bar chart, it has a title and it has a subtitle indicating what's the source. So that's also good practice, showing what's the source. But different than the bar chart that we had seen before, now we have this text right here. So this is called the legend, and the legend is just going to help you read and understand this pie chart better. So for example, we know that red represents 4F series and then blue represents other models. Now, so those are pie charts, and next we have questions about pie charts, but I want to see if there's any questions in the room about pie charts. Someone asked in the chat, why is my Christmas tree up? Now you guys know why I didn't want to show my screen last time, because I had my Christmas tree still up. That was funny. Okay, so I'm reading out your question. So do we always have to display the absolute and relative frequencies in a pie chart? This is a great question. So no, we don't always have to show both of them. We can make that decision as data professionals, what data we want to show. So do we want to show maybe the name of each one of the slices on top of it? Do we want to just show the frequency, relative frequency, or the absolute frequency? At the end of the day, your goal is to make the data as transparent as possible for your reader. So as you start working with more data, you'll realize what are the best practices, and also it depends on the data that you have. Sometimes if you have too many slices, what do? Do you show all the numbers? Do you show only a few numbers? And we'll see some of those examples coming up. Okay, so I see some questions asking like, how do we display this on Excel? There's going to be a future case, not today, but there's going to be a future case where you're going to learn how to do that. Okay, so awesome. So I think we're almost to the hour, and we usually take a quick break. So we can take a 10-minute break if that sounds good with everyone, and then we can meet again for the continuation of this lecture at 2 p.m. Eastern time, and make sure that you have the correct time on your time zone. So 2 p.m. Eastern time. So let's see all of you again at 2 p.m.
But let's reel back, y'all. We've had a little bit over a 10-minute break. So yeah, let's bring it back. Okay, we're gonna go back as our coming back session question. We're gonna go back into time. What was actually, yeah. How about you share a picture in the live chat, if you can, of your first phone that you ever had? What was the first phone or cell phone that you ever had? Okay. So
I don't even remember the name of my phone. I remember how it looked like, and it had an orange screen, but I don't remember the name.
yeah, it's funny. I never had a phone until I was 18 and in college already. So it was, yeah. So most folks are saying Nokia. Okay, a lot of folks are LG. There's a clamp phone. There's a Samsung. There's, oh my goodness, what is this called? That Verizon, is it? Gosh, I don't remember the name of it, but Marcelino just posted it. Someone posted a picture of cups with string. Okay, interesting. And here we are on iPhone 14, iPhone version 14, and etc. So awesome. Thank you all for sharing. I loved razors. Thank you all for sharing and partaking. Welcome back. We're gonna hand it back to Viviana and finish up this case.
Sounds awesome. I think I was able to find my phone, actually, my first phone that I had when I was like 9 years old. I don't know why my parents gave me a phone when being so young, but it was this one with the orange one, and you could play like a box game. I don't know. I love that phone. It's definitely an old memory I had forgotten about. So thank you, Ivan, for that question. I loved it. All right. So how's everybody feeling this Saturday afternoon? We're learning about data. So we're becoming the new scribes, as we talked in our first case, where we're learning data literacy, and we're becoming the new scribes of society. So I love the enthusiasm. I feel like that enthusiasm deserves this sound. Okay, awesome. So what were we doing today? So let me just make sure I'm sharing my screen. Yes, I'm sharing my screen. So what are we doing today? So today we go to the year 2020, and we work as data analysts for a car dealership, and we're trying to figure out what cars were sold the most, so our car dealership is ready for the demand, the upcoming demand. So while we were doing this, we learned about tables, we learned about pie charts, bar charts. I see that in the chat we're having here a little bit hashtag team bar charts, hashtag pie charts. It's creating a big division of feelings, but cool. So as we're learning throughout about these different things, there's something that I wanted to show you all, and it's the power of good visualizations. So I'm gonna show you an image, and if I show you this image right here, and I ask you to tell me how many letter B as boat are in this image, it's probably gonna take all of you a few moments to count it, like how many letter B's are in this image. However, oh wow, you guys are way faster than me. It definitely took me several minutes to count it. But if I do this right here, for people that are a little bit slower like me, I definitely was able to count right away right here that there were 5 B letters just by changing the color of the letter B, because that was in this case, the important information that I wanted to convey was how many letter B's are there. So if I show this image right here, it's the same information, but it takes you a little bit longer, and also you're not completely sure if you missed one or you didn't miss one. But if I show you this image right here, you can quickly find them in a matter of seconds, how many letter B's are there. So that's the power of visualizations and good visualizations. So a lot of the questions that we were getting on the chat were, how do we choose a bar chart? Like, do we choose a bar chart? Do we choose a pie chart? And as we were mentioning it before, it's important to understand your data so you can make the best choice as a data professional of which type of chart to use, either a pie chart or a bar chart. But in my case, a good rule of thumb that I do is that I show someone in my house that is not familiar with the data at all, and I tell them, and I'm like, hey, come over here, look at this chart, can you understand it? And because they're not familiar with the data at all, it's the first time that they're seeing it. If they're able to tell me in a few sentences what the chart is trying to convey, then I know that I did my job right. Where if they start saying things that are not necessarily correct, or it takes them a really long time to figure out what the, I don't know if it's a bar chart, like what the y-axis means, the x-axis means, etc., I can see the flaws in my chart that way. Because that happens often, that after you've been working with the same data set for a really long time, you're super familiar with it. So something that seems very obvious to you might not seem obvious to your boss or obvious to your client, etc. So that's always a good rule of thumb, to just ask someone that is not very familiar with the data to tell you, like, what do you think of this chart? Like, can you figure out what it means just by looking at it? So that's a good strategy. And I love the comment that Shinita left on the chat about color blindness. It's very, very, very important when you're doing, for example, a pie chart where colors are important, that you pick a color palette that is color blindness friendly. So you make sure everybody has access to the data, because if you pick colors that people that have color blindness can distinguish, then your message is lost. And a follow-up question to that could be, how do we pick those colors? Actually, I think PowerPoint has just like the option where you pick a scheme of colors that is color blind friendly. So that was a great comment. All right. So another question that I saw is about pie charts and absolute frequencies and relative frequencies. So a pie chart, just by the nature of it, the whole circle represents 100%. And then once you start taking the different slices, you start representing the different percentages. So by its nature, the pie chart is showing the frequency, the relative frequency. However, you can add on top of the pie chart numbers, the absolute frequency numbers, if you feel like that's going to help you convey your message better. And then following up with that question, I see that a lot of people in the chat say, how do we do negative values on a pie chart? The answer is you can't, because in percentages, you're just doing unless you're doing some type of, it wouldn't really make sense, because it would be very wordy to try to explain that you did a pie chart of 100% that is a negative 100%, and you took negative slices. It would be too wordy, and then your message is going to get lost. So just since we're dealing with percentages, it should be all positive. It should all of them add to 100%. And this is a great example where if you have, for whatever reason, you have negative values in your data set, maybe you're better off with a bar chart and not a pie chart. So that was also a great question. So no negative numbers on the pie chart. Okay, so now that we have learned about the pie charts, let's go with a question. So question, let me just zoom this out a little bit. Okay, so now this is a new pie chart. So this pie chart is the equivalent of the bar chart that we were doing earlier today. So this one is including the top 10 models. So do you consider it to be easier or more difficult to read, and why? So everybody's saying like difficult to read. It's there's too many details, more difficult, harder. It's not understandable. Someone said okay. So that's great too, like if it works for them. But I feel like the big majority of you are saying that it's hard. And I agree that for me, this is hard. First of all, we have too many colors. So the colors they don't really mean something other than distinguishing the different models, makes and models of the cars. So it's a little bit overwhelming. Because usually when you're doing a visualization, you want to use colors to be able to convey certain information that is relevant. But then here you're just using multiple colors to distinguish different types of cars. Another reason why is that there's too many categories. So it's hard for me to say to just look at this slice right here and calculate like what is the percentage of that slice represented there. It's also harder to start comparing the different slices. So which one is bigger than the other one? So in this case, if we wanted to show all the top 10 models, maybe a bar chart would be better, because the bar chart, then you can just use the axes, you can use the grid lines, you can use the numbers that are in your y-axis, etc. So this is probably one of the reasons why people usually tend to prefer bar charts over pie charts. However, pie charts are still useful, but they work best when the number of categories is reasonably small. So I would say 5 or less. So in general, bar charts should be your first option to answer some of the questions that we had seen on the chat, like which one do I use? Do I use the bar chart? Do I use the pie chart? So in general, bar chart should be to go, like your first option to go. But sometimes a pie chart could be more easily understood, and we'll see an example now about that. So for example, here, so one of the issues that we had with the previous chart, the previous pie chart, let me just make this bigger so it's easier for you all to see. So one of the issues that we had with the previous chart is that there were too many categories. So how do we solve this? One option is to just take the top 3 categories and then just aggregate all the other categories into a bigger category called others. And this pie chart is interesting because it's easier to read. So this is much more easier and friendly to read than this one right here. Just because you have only 4 categories, but also there's another information that we hadn't noticed before here. And is that the top 3 brands account for about half of the sales of all the brands, the top 10 models that we were looking at. So this specific pie chart right here is giving us an information that we hadn't been able to see through the bar chart or to the table, because we aggregated it this way. So it's interesting to see if you have to make any type of business decision. Oh, I need to have 50 like my top 50% percentage sales, like what are the brands that are accounting for the 50% of sales, then you see that are these 3 brands right here. So it's interesting to see all the different things that you can see with a pie chart and a bar chart. But however, if on the other hand, you do need to know the information about the other brands that are lumped here in the others categories, then maybe you do need to switch to a bar chart. So it depends on what your objective is. So one question that I see on the chat is, what does it mean to aggregate data? So to aggregate data is just to sum rows in a table. It could be, there's many different aggregation functions. So you could either do a count, you could do a sum, you could also do the average, etc. So basically it's computing a function, a math function on a set of rows. So that's what I mean by aggregating data. In this specific case today, what I mean is that we're just adding the other ones into the other category. So in this case here. All right. So another question that I see here in the chat is, can you edit the other category? So it depends on what you want to show. So for example, if for whatever reason within your business context, it makes sense to show that only 3 brands are accounting for almost half of your sales, then you aggregated the data this way. But if you needed to show different things, that's going to be your job as a data professional to see what is the best aggregation of your data and what type of analysis you need to run on them. And don't worry, this is just today. The objective for today is to get familiarized with bar charts, pie charts, tables, absolute frequency, relative frequency. And then as you go throughout this program, the data analytics program with correlation one, you'll start learning how to do these aggregations and how to come up with the best data analysis that you can do. All right, so let's just go on to the next example. So I have another exercise right here. Okay, so let me just zoom it out. Awesome. So this is a pie chart of total sales by car make. So previously we had plotted total sales by car model. So let's just quickly go back to the table in case I feel like that was a while ago. So this is our table. This is the data that we are using to create either our bar charts or our pie charts. So we have 2 columns. We have the make, we have the model, and we have the amount of cars that were sold within that period for a make and model. But we see that for the model, they're unique, but for the make, we have the values are not unique. So for example, we have 2 Toyotas. We have Toyota, this RAV4, and we have the Toyota Camry. And then we have Honda CR-V, and we have Honda Civic, etc. So notice that the percentages, the numbers are going to be different, because if we wanted to do the frequency, the absolute frequency per make, then we will have to aggregate. So we will have to add the values. So for example, add the values for the Honda. So what would be the total of Honda cars that were sold? What were the total of Toyota cars that were sold? Because in this case, we're not looking at the model. So that was the table. And let's go back to our pie chart. That was exercise 5. So notice that previously we were using that second column, that it was the model where all the values are unique. Now we're using this first column that is by the make, and we saw that the make is not unique. So the absolute frequency and also the relative frequency of the make is going to be slightly different than if we look at the model. So So we have it here. So for example, we see the top of them. So Chevrolet is the blue one, Ford is the orange one, GMC is the yellow one, green is the Honda is the green one, and then all the other ones we have aggregated here in others. So let's just try to estimate the relative frequency to fill the missing spaces here. So just by looking at this chart, we haven't computed those numbers. We could easily go back to the chart and then just take our calculator and add like all the Hondas and come up with the number. But just by looking at this chart, what we can estimate the relative frequencies of each one of these brands. So let's just do it with Chevrolet. So we want the relative frequency. Let's remember that relative frequency is referring to the percentage. So we have Chevrolet over here. So what would be the percentage for Chevrolet? And I love the answers in the chat, the interactions in the chat. Yeah, so these numbers that I'm seeing in the chat are pretty accurate. I cheated. So beforehand, I computed the numbers just so I could show it to you all. But the numbers that you all are giving me are very accurate. So for the Chevrolet, we have approximately, I saw a lot of 20, 21, 22%. So that was a very good guess. Then for Ford, it's 20.5%. For GMC, it's 5.96%. For Honda, it's 14.88%. And the others 36.97%. So that's the beauty of the pie chart, that even though I only showed this to you all, like it didn't have any numbers, it didn't have any percentages, and a lot of you were able to come up with the percentages just by looking at it. So for the ones that were being pie chart haters, that would be a good reason to use pie charts. It's easy to learn to have an intuition of what the percentage of a slice is. But if you like the bar chart, you can also use the bar chart. So you as a data professional have that power in your hands of deciding which visualization is the best one. So let's just take a moment and go back to the first table. Let me just pull it up here on another tab. So this was the first table that we saw, because I see that some of you have questions. So originally we were looking at the model of the car, but for this pie chart right here, we are, let me just sum it up. We are looking at the make. So this is the make. Oops. Okay, so this is the make of the car. We're looking at this column. So remember that the pie chart, what you want to do is that the whole circle, the whole pie is 100%. And then you want to be able to express each one of the categories as a slice. And what is the size of the slice? The size of the slice is the relative frequency of that category. So for example, in the case of, let's look at Honda. So we know that if we add all of these values in total, this dealership sold about 1.7 million cars during January 2020 and June 2020. So for example, for Ford, we can see to compute the percentage would be just to do this number divided by the total of cars. So that would be the percentage of Ford. But then for Honda, since we have two values right here, we would just add these two values and then divide it by the total number of units that were sold. And that's how you get the percentage. But as some of you have mentioned it in the chat, no one here was looking at any numbers when they were trying to answer these questions right here, like to estimate the relative frequency, they just were looking at the chart. So that's the beauty of a pie chart, because you can just look at it and know what is the relative frequency without knowing any numbers. So if you wanted to know the exact numbers, then we will have to go on this chart, all add this column, come up with the total number of cars that were sold, and then divide it, and then get the percentage. But the beauty of the pie chart is that you can quickly just look at it and come up with conclusions right away. So for example, for Chevrolet, we see that Chevrolet, we would say, like, let's say this is half of the pie chart, that would be 50%, and then half of the half would be 25%. But this is not quite, for Chevrolet, which is the blue one, it's not quite half of the half, so it will be a little bit less than 25%. That's why some people in the chat were guessing 20, 22, 21, 25. Some of them were guessing 25. So you know that it's almost 25. You don't know exactly the exact percentage, because to be able to know the exact percentage, you would have to compute the math. But if you just want to grab an idea of what was going on, so how many Chevrolets were sold, you can just look at the pie chart, and you know that was like between 20 and 25% that they were used. So that was a great question that we saw in the chat. And so just to confirm your eye intuition, just to confirm what you were doing by eye, I just went ahead and computed the math for all of this in case any of you wanted to see it. So basically what I did is that I aggregated the make by make, the frequency. So I made the frequency table by make, because the first frequency table that we had was by make and model. So now this frequency table is just by make. So we have the total number of Chevrolet cars, the total number of Ford cars, the total number of GMCs, etc. So we see all the different percentages. And with those percentages, we built the pie chart. So that would be something else to point out, is that to be able to build this pie chart, you would need to know these numbers. So you will have to go on Excel and compute these numbers and know them to be able to create the pie chart. So as a data professional, you're going to have to do that to be able to build the pie chart. But for someone that is just consuming the information you're providing to them, the data that you're providing to them, they can just look at the pie chart and get a good sense of what are the makes of the car makes that were the most popular ones. All right, so before we jump onto what did we learn today, I wanted to open it up for questions. Please feel free to unmute yourself, raise your hand, or use the live chat.
Hello. Hello.
I heard a hello, we hear you.
Yeah. Can you hear me?
Yeah, I can hear you.
Yeah, I want to find out, how do we put this on Excel?
So we're going to learn that in the next case, actually.
Okay.
So we're going to learn how to put information in Excel and do some basic operations in Excel. So we're going to do that later today.
For both the bar chart and the pie chart.
No, so the bar chart and the pie chart, that's going to be a different case because we're taking step by step. So the first step was to get familiarized with bar charts, pie charts, tables. So next time you see them, you know what they mean and you can understand what is the message the message behind those pie charts, bar charts, and the table. And then today, in our other case that we have at 4 p.m., we'll just do our first steps in Excel of just how to put in the data in there and how to use the different columns and some basic operations in Excel. But I'm excited to hear that everybody wants to know how to do that in Excel because that means that you guys love it. So don't worry, don't worry. You guys are gonna learn how to do this in Excel and throughout this whole data analytics course by correlation when you're gonna become data experts. So you're
I
gonna
have a
become the
quick
new scribes. Yeah, go for it.
For the formula I was following you for to get the percentage, you say we add the number of cars sold plus what was the other thing on the top at the beginning of the charts when we first started? You say in order to get the percentage, we need to add the cars sold plus what's the other one?
Yeah, it's a great question. Let me just pull the other chart over here.
Great, thank you. Appreciate that.
Yeah, of course. So the first chart that we got at the beginning of the lecture was this chart, this table that has 3 columns. So it has make, model, and cars sold from this period of time. So if we wanted to compute the percentage of it, you can compute a percentage in many different ways, but one easy way to do it is that if we wanted to do it per row, so in this case, we want to know the percentage per model, you just grab the total of them. So you add all of this column to know what's the total of them. So I had that total somewhere here. So here, this is the total of units sold. So if you add all that column, you're gonna get that total, this number right here. So that's 1,792,146. And then if you go back to the table, if you want to compute the percentage, then you compute for each one of them. You grab this number. So for the case of the F series, you grab the 367,287 divided by the total number. So 1,792,146. And then times 100, then you get the percentage. There's many ways to compute the percentage. That's a way. So you grab the single instance
What about
divided
for the pie chart, like for the single, like more specific to like the Chevrolet, for example? That's the one.
Right. Right. So so this is just a computer for the make and model. That will give you this pie chart right here, which is for the make and model. If you want to do it just by the make, you'll notice that there's some makes that are repeated. They're not unique. So you will have to first add those makes. So you have to add the Honda one. So you would add 138,898 plus 127,858. So that'll give you a number, and then that number you'll divide it by the total of units sold times 100. I know that this might have been a little bit too much because I'm not using a whiteboard, but if you have any questions, always feel free to ask again in the chat or ask your TAs, and we can give a more explained, like a more detailed explanation with some visuals.
No, it's great. Thank you. Thank you. Appreciate that.
Yeah, of course. I think Tiguimbie is, you're raising your hand. And please correct me if I mispronounce your name.
Tiguimbie Nadej. My question is, can you go through the absolute frequency again?
Sorry, I couldn't hear. Could you repeat your question?
Can you go through the absolute frequency? I didn't get that part.
Yeah, of course. That's a great question. So for absolute frequency, absolute frequency just means the total number of counts. So for example, in this case, we have the Ford F-Series. the absolute frequency of Ford F-Series is this number. So when you hear absolute frequency is just the number. When you hear relative frequency is the percentage.
Okay.
So absolute frequency, just the number, the total count of that particular model of car. And then for relative frequency is the percentage.
Okay, thank you.
Yeah, of course. Do we have I see a question in the chat. So someone is asking if absolute frequency is found with sum. Yeah, so imagine if you are in this car dealership and you have all your cars and you listed all your cars. So you listed your Ford F-Series and then you listed a Honda Civic and then you have another Ford F-Series. So you have this huge table with all the cars that you have, and maybe you have an unique identifier for each one of the cars, maybe like the series number or the identification number of each specific car. But then to find the absolute frequency of the Ford F-Series, you would sum all of them, you would count all of them, and that's how you get the absolute frequency. We have a question by Lily.
Hello. Yes. My question is, it's possible, I think, in the P chart to get a valid frequency and absolute frequency?
Yeah, so that's a great question. So if I heard correctly, your question is if in the pie chart we can have both absolute and relative frequency?
Yeah.
Yeah, so as we can see here, you can have both. The main objective of the pie chart
No,
is
no. I forgot. In the bar chart. No. My question is the bar chart.
in the bar chart. Yeah, of course,
Yeah.
you can have it too. That's actually a really, really great question in the bar chart, because in the bar chart, we only saw the absolute frequency. We saw just the numbers. Oops, here. So we just saw the numbers here on the y-axis, but you can also make your y-axis percentages. So instead of showing the absolute numbers, you could show the percentages, and that would be the relative frequency. So that was a great question. Yeah, you can show the relative frequency in the bar charts as well.
Okay.
Don Charis, you have a question?
Hello. Yeah, so it's Don Cheshire, but thank you, Vivian. Nice to meet you.
Thank you for correcting me.
Yep, no problem. On the last pie chart you did, is that just a random selection of four groups of cars? Because like GMC's, the last on the list, you would think they would show the 4 top car producers and then have the, lowest 6 in the other. But here where they've got the yellow one, the GMC there, it's at the end of the list. I'm just wondering why they don't have like Toyota in there or something. The top 4 manufacturers, I guess, is what I'm wondering.
Right. So for Toyota, let me just do a real quick some math here. So for the Toyota, in total, we have 183, 360 plus 125, 899. So for Toyota, we have 300 over 300,000. Yeah, so that's a great question. I would probably have to ask the content creators of the course, because maybe it was just more to show a different size of slices, since GMC was significantly smaller. GMC was only 5%, so you could show how a smaller slice would show in a pie chart, where Toyota is almost 20%, so it would be about the same size as the Chevrolet and Ford. But it could also be that in the business case, your boss asked you specifically for GMC, so you had to show it. Yeah, but that's a good catch. That was a good catch.
Okay. Well, nice talking to you. Have a good night.
Yeah, of course.
Hi, Viviana.
Hi. I hear someone talking.
Yes. Viviana, can you hear me?
Yeah, I can hear you.
Okay, please, can you take again the relative frequency? I didn't really get it.
So whenever you hear the word relative frequency, just think about the percentage. So how much of all the data that you have, what's the percentage of it? So for example, there were over 1 million, almost 2 million units sold of cars, but of Chevrolet, in this specific example, there's only 388,693 of them. So if you take this number, which is the total number of Chevrolets that you have over the total number of cars, you get the percentage. So relative frequency is just expressing how many items do you have of that particular category just in a percentage. Instead of using a number, you use a percentage.
So how do I get it? Is it like, how do I get it? Is it by dividing,
Yeah, so just by dividing the total number of items that you have of that category over the total numbers overall
number.
in your data set. Yeah.
Oh, okay. All right. Thank you very much.
Yeah, of course.
Multiply by 100.
Yes, I hear that.
Multiply by 100.
Okay. Yeah, multiply by 100.
Okay, thank you.
And just as the name says it, relative frequency is to show how relative data is to its peers. So you can say I have 20% of my cars are Ford compared to the rest of the cars. So the name, you can think about it that way, like relative means just how it relates to the rest of the data.
I had just one quick question. So are we like charting this for today's case, or because I mean just putting the answer just plainly, or trying to make the chart also? Like
that's a good question. So for today's case, for this specific case that we just saw, we've reached our end. Like we're not gonna do more things with this specific set of data. However, on the second case that we're gonna see later today, we're gonna use a new data set and do some of the things that we learned today. So just how to put the data on Excel and how to do some basic aggregations on Excel. So it's not gonna be exactly the same data set because what we want to do here at Correlation One is to expose you to different types of scenarios so you're more familiar with them in case you see them once you're working in the industry as a data professional. So it's not going to be exactly the same, but like the data is not going to be the same, but the concepts are going to be the same. So the next step in the next case is going to be to get our hands on Excel.
Okay, thank you.
Yeah, of course. Do we have more questions?
I had one question real quick.
Yeah, of course, go for it.
So just so on the same page, so I know you just explained this, but so the absolute frequency is just the number of cars, and then the relative frequency is just the percentage of cars out of the total amount of cars that you have, like.
That's right. So absolute frequency is just the count of that specific category, and then relative frequency is the percentage of how many cars of that specific make or model, depending on what question you were answering, compared to the total of number of cars.
So like for Chevrolet, it's 21.6 0.69% out of 1,792,146.
Sorry, can you repeat that? Your microphone is a little bit,
Oh, I said, for Chevrolet, it's 21.69% out of 1,792,146 cars.
exactly. So out of the total number of cars, 21.69% of them were Chevrolet.
Okay, all right, but yeah, I just wanted to make sure. All right, thank you.
Yeah, of course. I see that Mohammed has a question, and then after Mohammed says his question, then I'll continue with the lecture. So yeah, Mohammed. I think you're muted.
Hello.
Hi, I can hear you now.
Yeah, though you might have explained it, probably I missed or I don't know. Can you please explain how do we show relative frequency in a bar chart?
Yes. So in a bar chart, and I really like this question that we had seen before. And so, for example, we have here the bar chart, and in the y-axis we have the numbers of just the absolute numbers. If you wanted to do with relative frequency, you just, instead of using the absolute numbers, you just put the percentages. So it would be with the percentages instead of the absolute numbers.
Okay, it's okay. On the y-axis, we need to replace the number of units to percentages.
Exactly, percentage, exactly. So instead of units sold, it would be percentage sold.
Okay, fine. Okay, thank you.
All right. So one last question before we go to the conclusions. So Robert, Robert, I actually have a friend with the same name, Robert Walker. Are you my friend? Hi.
I could be. How you
He lives
doing?
in Iowa. Do you live in Iowa?
No, Florida. I'm sorry. First and foremost, I want to thank you. Thank you for your patience, and thank you for the way you are delivering this lecture. The only question I have is, how many people are actually paying attention? Because you happen to repeat a lot of stuff that I think that you shouldn't have to be repeating. I don't want to come across rude to anybody, so please, anyone, please do not take this as coming across rude. This is my first time ever doing Excel. I've never touched anything. I'm learning a lot. I'm being very attentive to this class, but I keep hearing the same questions. So it's like, man, I know this is going to go on for 17 weeks. I already know that. I'm prepared for it. But this is not necessarily a question to you. This is a question to everybody. Are you taking this class serious? We 3 weeks in. Are you taking it serious? Because for the newer people, I understand the questions. I understand the questions coming. But it's difficult. It's difficult for me to even want to raise my hand, because I'm wondering if it's somewhat intimidating, because it's like, is it harder than what it is if we actually paying attention? That's all. That's the only thing I have. I'm sorry.
Thank you, Robert, for your comment. I don't mind answer questions again, but I understand why you're saying. So this is a safe space for all of us to learn. I understand that there's many languages, people working, etc. So yeah, I think it's a good constructive feedback if we all can pay a lot of attention, but I also want to reiterate that there's no silly questions. So feel free to ask in the chat and ask to
Thank you.
your TAs and stuff. But I appreciate your kind words, Robert, and I'm excited that you're here and that you're excited to learn that.
Thank you, Vivian.
Yeah, of course. So, okay, we were talking about bar charts, and now I'm gonna jump to the conclusions and takeaways. So I'm just gonna do a quick recap of what we did today. So we know what are the takeaways, and then I'm gonna pass it to Ivan for announcements, general announcements. So what did we do today? So today we imagined that we traveled back to the year 2020 and you were working as a data analyst as at a car dealership company. So in the car dealership company, your task was to determine what were the cars that were sold the most. So with this information, we learned multiple things today. So we learned how to read a table. So a table has columns, it has rows, it has cells. And then once we had those tables, we learned about frequency tables. So we learned about absolute frequency. So whenever you think about frequency tables, it's a table that has a column that is counting something. And then an absolute frequency is just that counting that something. And then for the relative frequency is just the percentage. That frequency is expressed as a percentage. We also learned about bar charts, pie charts. I saw that we were seeing people here that they were team bar chart, team pie chart. So now you're very well equipped to write your summary and hand it to your boss, either with a pie chart or a bar chart. So you'll do the best decision as you think it fits your specific business context problem. Yeah, so that's what we did today. Now there's only a few minutes left for this specific case, so I'm just gonna hand it to Ivan for some announcements I assume you would have. So hi, Ivan.
Hi, thank you. Thank you so much for that, Viviana. And I think, again, to also reiterate, right, we appreciate the question, and right, we similarly, right, we've been together for almost 3 weeks. Usually I repeat the same things over and over again. It is 1000% okay. I don't mind it. Right, we understand that, as Viviana mentioned, right, folks speak different languages, different things. Some folks are single parents, multiple jobs, etc. So, but if you have specific questions or etc., please feel free to list them in extra help or in your TA pair channel. We will get to them as well. So you all, we have about an hour between now and our next session. So during this time, please feel free to use it how you see accordingly. If your team wants to meet, etc., please feel free to use this time as well. Use the huddle, meet, talk about mini project 1, etc. All of our TAs are available on Saturdays. So everyone should be here to help and support. So if you have any questions, please feel free to tag and ask for support, etc. So yeah, we're gonna take our break, and after this, we'll come back for our next hour session. So please feel free to do as you see fit, as your team sees fit, and I'll be available for any questions that folks might have. Oh, wait, quick comment before we go. I keep on forgetting. So give me one quick second as I grab this knowledge check, which I had been meaning to do, but I just forgot. So I'm gonna paste this knowledge check in the polls and answers channel for us to fill in, etc. So please feel free to do that. And you don't need to comment that you've done it, etc. Once you've done it, great. You don't need to let us know. It is completely fine. Here we go. Knowledge check here. And the last thing also is most folks were asking about creating or having these channels, right? Dependent on your region, etc. So I went in and I created channels for folks to connect, to meet one another, etc. So if you go to the Slack bar on the left-hand side, there should be a new drop-down menu called Region and Cities. So once you click on regions and cities, you will see all of the cities where folks are from: Atlanta, Austin, I misspelled your name, Bay Area, Boston, etc., Little Rock, LA, Vancouver, everything's here. So once you're here, you can basically click on the channel and then add yourself to the channel by clicking this top right-hand person thing that once you click, it'll say add people to channel. So I didn't want to add people personally because some folks might not want to be added. So I'm leaving it up to you all if you want to choose to join these channels with other folks from your region. Please feel free to do so. I won't be adding any people. So yeah, so I wanted to share that as well. Awesome. Let me stop this recording and I'll take a few questions. But other than that, everyone, please feel free to enjoy your break. We'll be back within an hour.